In this video, we'll build a polished and beautifully animated mobile app complete with a custom onboarding flow, sign-in model, animated bottom tab bar, and an interactive sidebar powered by Rive Icons. It's responsive, supports light and dark mode out of the box, and the UI feels fluid and dynamic at every step. Whether you're here for the design, the animations, or the engineering behind it, this walkthrough will take you through the full build process from scratch. Before we dive in, huge thanks to the original creator of the app, Design Plus Code. This project is inspired by the Swift UI plus Rive course created by Mangto. In the course, he walks through building the same app using Swift UI and also teaches how to create your own custom Rive assets using the Rive editor. It's completely free and includes both videos and articles. I'll drop the link in the description. Highly recommend checking it out. Alright, let's get started. I've already set up the base Ionic Angular application using standalone components and Capacitor. To render the Rive assets, we're using a community package called ng-rive. I've also prepared all the necessary assets, icons, images, Rive files, and fonts. In our variables.scss file, we define the theme colors, font families, and different font variants. To ensure our app covers the full screen, rendering behind the status and navigation bar, we set the overlay web view to true for Android, at least for the older devices. This is already the default behavior on iOS. First, let's generate a new page called course-rive. We delete the default home directory and remove its route. We also update the app routes to redirect to the new page. Now let's create a views folder and generate an onboarding page inside it. And remove the auto-created entry in the app routes as we won't need it. I'm renaming the component selector to CR onboarding, where CR stands for Course Rive. This naming convention isn't required, but I'm going to follow the same for all the components that we're going to create. Since we're using standalone components, we need to import all the required Angular components and modules manually. So I'm just going to import them all at once that we're going to need for this component. Let's replace the default HTML with an empty div. Now to see the UI, we need to import our onboarding component into the root with other necessary imports. It's obviously throwing an error because we have removed their imports, so we're just going to replace the root component's HTML with our CR onboarding tag. Now for the Rive setup, in man.ts, we need to provide the path for our Rive assets. Since our assets live in a custom folder, we specify that path here. Rive also needs Angular's HTTP client to load the assets. So we need to also add that as a provider, and finally add the required imports from the package in onboarding. Our first Rive asset is called Shapes, a background animation of floating shapes. The animation type is loop, so it keeps playing unless we stop it manually. The Design Plus Code course already explains how to create this in detail, so definitely check it out if you're curious. To render it, we use the canvas component from the Rive package, specifying the file name in the Rive property and state machine via Rive Animation tag. It doesn't show anything, so we set the animation to autoplay. We want the canvas to fill the entire screen, so we use Ionic's platform service to get screen dimensions and pass them as canvas width and height. And it looks much better. Next, we blur this background by adding a Rive-bg class with a CSS blur filter. And behind that, we add a spline background with absolute positioning. Right now, it is covering the screen's width, so to enlarge it, I'm going to add a fixed width of 840 pixels, which is just 1.5 times its original width. And now to shift this to the center horizontally, we can add left of -50% and right of 0. Next, translate X and Y to move it to the bottom right. And finally, a blur filter similar to the shapes view, as they are only working as a background. Now to the main content, we add a content container div with absolute positioning, top and bottom 0, and with 100% to cover the whole screen and show on top of these backgrounds. Next, let's add the title. Right now, it's showing behind the notch, so we'll give the container safe area top padding with some extra space, around 80 pixels. Then, we will set the title color to black, font size to 60 pixels, and font family to Poppins Bold. We'll also wrap it in a title class to set a max width of 260 pixels. That's because the width doesn't apply directly on the text element for some reason, and we want the text to look consistent across all devices. After that, we'll add a subtitle, styled using the body font variation from our global theme. We'll give it a slightly dim color in CSS and a bit of top margin for spacing. Lastly, let's also add a padding of 40 pixels on the container. Below that, we add another Rive asset for a button with a fixed width and height of 236 and 64 pixels. Inside that, Rive player tag with animation name, play, mode of one shot, and along with that, auto reset to reset the animation after a trigger. Now if you're wondering where this fixed value of width and height came from, this is how it's specified in the Rive editor for this animation. This animation smoothly scales the button along with the border animation, and unlike the shapes animation we saw earlier, this animation is of type one shot, meaning it only plays once per trigger. We wrap this with an Ionic button container and add text start the course and an arrow icon to show on top. Now the icon is not visible because we need to define them in the component to load them correctly. So for simplification, we're just going to define all the icons we will be needing for this app in the root app component using add icons from Ion icons package, and now it's visible. Now let's overlay the text and icon on top of the Rive button animation. We'll use CSS grid for that, and to keep everything aligned within the same space, we'll set both the grid row and column to 1 for the child elements. Then we'll style the button text, set the color, font weight, and a Z index of 1 to make sure it shows above the button background. We'll also center the text using the text align center. At this point, the container is still stretching across the full width. So let's match its max width and height to the button asset. We'll size the icon next and use flex properties to center everything inside the button. Then a little spacing and alignment for the text. It's still a bit off center visually because of the extra space taken up by the orange background behind the button. So we'll tweak it slightly using translate X and translate Y to center it perfectly on top. Finally, let's add some shadow beneath the button. We'll create another div, give it the same content class, and also apply a shadow class for styling. Set its background and height to 100% so it matches the button. Then move it slightly downward to create the illusion of box shadow. We'll add a blur to soften it and set its Z index to -1 so it appears behind the button. Lastly, let's add some vertical margin around the button for spacing and set the cursor to pointer since it's clickable. Next, add the footer text using the footnote font variation from our global theme and apply the same dim color as the subtitle. To move the button and the footer down to the bottom of the screen, we'll use a spacer div with flex 1, but that alone won't work. We also need to set the container to display flex and add flex direction to column. Then we'll add a padding bottom of 40 pixels along with safe area inset support for devices with notches and set overflow Y to scroll. This ensures the layout is scrollable on smaller devices with limited vertical space. Now we want the button to trigger an animation when clicked. So we'll define a button toggle variable in the component and set its default value to false. Then we create a function called start course pressed where we set the button toggle to true. In the HTML, we bind this variable to the play property of Rive player using two-way binding. And we call the function on the button's click event. But there's a problem. If play is false by default, the button won't render initially. It only shows after it's clicked, which is when the variable is set to true. So we try setting it to true, but now the animation won't replay on click. Now quick disclaimer here. The Rive package we're using isn't official. It's a community package that isn't actively maintained at the time of this recording. It works well overall, but there are few quirks. And one of those quirks is with one-shot animation. They don't always trigger reliably. So we'll use a workaround, a way to reset the animation. We declare a new variable called showRiveButton and render the Rive player only if this value is true. Then we set the showRiveButton to true in ngOnInit so the button appears when the component loads. Next, we create a function called resetButtonState. This sets button toggle to false and then briefly hides and shows the Rive player using 100 millisecond timeout. This effectively resets the animation because the player is removed and re-added to the DOM, which wouldn't be visible to the user. In start course pressed, we call this reset function, but it doesn't quite work yet because the toggle is being set to false too early. So we add a delay before resetting the toggle, and now the animation plays again as expected. It still doesn't trigger properly on the first load, so we'll also call reset button state function in ng on init. One last issue. When the button toggle is initially false, the animation canvas won't show. To fix this, we delay the initial load slightly with a timeout, and now it behaves correctly. It's a bit of a hack, but until the package improves, this workaround does the job. Now let's move on to the sign-in model. First, generate a sign-in component. Change the selector to CR sign-in and import all the required modules we'll be using. Then, in the onboarding component, import this new component and render it inside the Ionic model. To display the model, we get its reference and show it after the button animation is completed. Inside the onboarding component, wrap the layout in an Ion page class and center the content. Next, in the sign-in component, add a container div followed by a title using large title font variation from our global theme. Below that, add a subtitle with the headline font style. To break it into two lines, wrap the second line in a p tag. In CSS, center align the text, apply padding 30 pixels to the container, and add vertical spacing to the subtitle. Next, create a title for the email input field using the subheadline font variation and a secondary color from our global theme. Align it to the start. Add an input of type email. It won't display correctly on its own, so we wrap it in an Ion item with a class called input container. In CSS, we set the border, background color to white, a border radius, and some padding at the start. The CSS variables with double hyphens are Ionic specific style properties used to customize the component appearance. Now let's add an icon to the input and set its width and height in CSS. For the input field itself, we add padding, set the text color to black, and align the text to the start. Let's also reduce the input gap with the title. Repeat the same for the password input field as well. Next, we add a sign-in button, use the headline font variation, and set the expand property to block so it spans the full width, and an arrow icon beside the text. In CSS, we customize the background color, but it still uses default styles for the click. So we provide separate styles for the hover and active states. Then, apply padding, set the border radius 8 pixels on the top left and 20 pixels on the remaining corners, and add a box shadow. Finally, add vertical margin and a small gap between the icon and the text. Below the button, insert an OR separator. Then wrap it in an Ionic row and place divider divs on each side of the text. In CSS, set the background color, height to 1 pixel and flex to 1 so the dividers can fill the available space. Align everything using justify content space around and align items center. Style the OR text with a dim color and add horizontal margin of 8 pixels. Add a bottom margin of 40 pixels to the button above to create a spacing between it and the OR separator. Now add a title for the social login section using the secondary font color and vertical margin of 24 pixels. Then insert 3 social icons for email, Apple, and Google. Inside another Ionic row, use justify content space between for layout and specify the icon widths and heights in CSS. Now to complete the model styling, we need to show the content area with border and shadow, while the rest of the background will be transparent. We wrap the content inside a gradient border div to simulate a frosted glass effect. In CSS, apply margin 16 pixels, a box shadow, border radius, border, and a white linear gradient as the background. It may not be visible at first, but this is consistent with the original SwiftUI app. To preview the effect, you can temporarily change the gradient to red and green. It currently covers the full container, but we want the gradient to appear only on the border. To fix this, apply a transparent background and a backdrop filter of blur to the child sign-in container. Also using the supports rule to ensure the browser supports these CSS features. If the content spills past the border radius, apply the same radius to the child container, but subtract the border width to keep the effect consistent. Now that we know how it looks like, we can change the gradient colors back to white. Finally, let's add a close button to dismiss the model. Use an Ionic button with a close icon, which has some default styles that we will override. Wrap it in a closed container div and set its position to absolute. Set left and right to 0 to center it and give it a top margin of 8 pixels. Change the button background to white using Ionic CSS variable and style the icon with a black color and a fixed width and height of 24 pixels. Also provide alternate background colors for hover and active states. Remove the button's default padding, set its width and height to 36 pixels and apply a border radius of 18 pixels. Finally, add a shadow and that completes the close button setup. Now we'll add input validation using Rive Animation from the community. This animation includes 3 inputs: check, error, and reset. You can find similar animations on the Rive marketplace and preview them directly on the site. For this one, we have the error and check animations, and to reset it back to the loader, we have reset input. Next, in the HTML, we'll use a canvas with a file name check and a fixed size of 100 pixels. We'll also specify the state machine name and define all 3 inputs in the component. By default, the canvas renders within the sign-in layout, so we wrap it inside a container div with absolute positioning, where top, bottom, left, and right set to 0 to have it cover whole sign-in container area. Use flex styles to center it. As the canvas appears behind the input, apply a Z index of 1, and it's also conflicting with the touch, so set pointer events to none to prevent any interaction interference. In the component, define variables for email, password, and isLoading. Bind email and password to their respective input fields. We'll hide the check canvas unless isLoading is true. Now create a sign-in function that accepts 3 parameters: success, failure, and reset. These are our state inputs. In the HTML, assign references to each input to trigger them individually. Then trigger the sign-in function on button click, passing in the 3 inputs. Inside the function, set isLoading to true right away. Then check if both fields are non-empty. After a short timeout, about 1 second, we trigger either the success or failure animation based on the validation result. It works, but it doesn't automatically hide. To handle that, we wait another 2 seconds, then set isLoading to false to hide the canvas and reset the animation. It's working as expected now. Next, if validation succeeds, we'll show a confetti animation. This uses another community Rive asset with a single input, trigger explosion. Like before, we set up a canvas in the HTML, this time with a dimension of 1500 pixels, and provide the state machine and input reference. Add the reference in our sign-in function and trigger the animation if the input is valid. It seems to be conflicting with check animation, as it is working after timeout, but loader animations are not showing. So we will give it absolute positioning as well. Now both animations work without issue. Next, let's wire up the modal closing functionality. Add an output property called onClose to the sign-in component and emit it when the close button is clicked. In the onboarding component, listen for this callback and dismiss the model when it's received. Optionally, after a successful validation, we can auto-close the model and clear the input fields. The sign-in model is now functionally complete, but we can make it look more like a model. Set the max model width to 600 pixels and background color to transparent. Set the backdrop color using color shadow variable from our global theme. Now this looks much better. As I mentioned earlier, the Rive package we're using does comes with a few limitations. One of the issues you might notice is that sometimes the assets don't render properly when multiple Rive animations are loaded at the same time. For example, if I reopen the app, the shapes animation might not appear, and the button animation might fail to load as well. To work around this, we'll declare a boolean variable called showRiveAsset and conditionally render the Rive canvas only if it's true. Then, during component initialization, we'll load these assets with a short delay. We'll apply a similar delay for the button animation, but stagger it slightly so there is a gap between the two render times. Now, if we reopen the app, the animations load much more reliably. Again, this is just a workaround, and ideally it won't be necessary once this is fixed from the package. But for now, this helps keeps things stable. Now let's customize the model animation. By default, Ionic models animate from bottom to top. We'll change that to animate from top to bottom, and also animate the onboarding content at the same time. We do this by setting the enter animation property on the model. The function receives a reference to the model's base element. To animate, we use animation controller from Ionic and define it in the constructor. Get the root element and create a new animation. Target the model wrapper. This uses a built-in class name applied to the model's wrapper element. Next, use keyframes to animate the models. At offset 0, translate it up by 100% of the viewport height. At offset 1, bring it back to translate y of 0 means it is visible on the screen. Also animate opacity from 0.5 to 1. Now to make the animations work, we need to return animation reference in the function which take base element as the main element. Set animation easing, duration, and add animation to group animations. And it seems to be working. You can also animate the backdrop. Use the from-to method to animate individual style properties. Here, we will animate its opacity from 0.01 to the standard backdrop opacity, as this is a built-in CSS variable used by Ionic. Add this to the animation group and return it. Now the enter animation works, but on exit, it still slides down. To reverse that, set the leave animation property to manipulate model's leave animation. In this function, we reuse the enter animation result and call direction reverse. That gives us a clean top to bottom entry and exit for the model. To animate the onboarding content along with the model, assign it an ID of container.
Then get its reference in the component.
And add a slight upward translate y of minus 50 pixels animation when the model appears. Add that to the animation list and it works beautifully. Now let's make sure everything looks good in the dark mode.
As you can see, we need a few adjustments to support the dark mode for both onboarding and sign-in UI. So in the HTML, let's add a main container class to the root element. Then in the CSS, we'll force the background to white.
For the sign-in model, we can provide dark mode color overrides for the text and background in our global theme file. This makes the UI consistent across both light and dark modes. For the OR divider, set text and divider colors that also adjust in dark mode. Everything looks great now.
Let's also test the sign-in submission flow just to make sure everything works well with dark mode enabled.
Finally, let's make sure the layout works well on the larger devices. On desktop, you may notice the spline background shifts too far left.
Let's inspect how the spline background behaves across breakpoints. And yes, it shifts too far to the left as we resize the window. And applying the margin auto seems to fix it. Also make sure we apply the same correctly in the HTML.
The sign-in model also needs adjustment at wider breakpoints.
It starts breaking the layout once the screen width crosses 768 pixels, mainly affecting height and introducing an unwanted shadow. To fix this, we'll use a media query to force 100% height and remove the shadow beyond that breakpoint. And now the layout stays consistent whether we expand or shrink the window. Aside from that, everything else works fine.
And with that, our onboarding and sign-in experience is complete. Responsive, animated, dark mode ready, and working across mobile and desktop. So first, we're going to generate the bottom tab bar component. I'll change the default selector name and import all the components and modules that we will need for this component. Next, we'll import the component into the main course Rive page so we can use it as a tag in the HTML. For now, I'll temporarily comment out the onboarding tag. For our bottom tab, we're using icons from a Rive community icon collection. Each icon has an animation controlled by a single input called active. In the HTML, we'll add an Ionic row as the container and give it a background color from our theme. Inside that, we'll add an Ionic column and use Rive's canvas element with the file name icons, along with artboard, state machine, and input name with value of true. For now, we're using just the chat icon from the collection. To position the tab bar at the bottom, we'll wrap it in a container div with gradient border class. We'll style with gradient border later on. For positioning, we'll set it to position fixed, align it to bottom using safe area inset, and add 8 pixels of extra space. Now let's make the icon interactive. We'll create a local variable called status with a default value of false and set it to true on icon press. In the HTML, we'll bind this to the icon's input value and call the function on click of the column element. However, the click isn't being detected properly. That's because the canvas is intercepting with the touch event. To fix that, we'll add pointer events to none to the canvas element. Let's check by reopening the app. Now the animation works, but it loops continuously and we want it to play just once. So after setting status to true, we'll add a 1 second timeout and reset it back to false. This way, the icon animates once per click and resets. Next, to render the other tab icons, we'll create a models folder and a tabs file. Here, we'll define an array with each tab's details, icon name, artboard, state machine, and other properties. Back in the tab bar component, we import this array and assign it to a local variable called tab items. In the HTML, we'll render the list using ng4 and add a track by function to ensure each icon has a unique ID. We'll also update the hard-coded Rive properties to use the values from each array item. Right now, clicking on one icon animates all of them. That's because we're still using a shared status variable. To fix this, we'll pass the individual tab item to the click function and update its status directly. We can now safely remove the shared status variable from the component. In the HTML, pass the tab item into the function and update the status value from that object. Now each icon animates independently, exactly how we want. Let's add a fixed width and height to each tab icon. In CSS, we'll add left and right to stretch it along the width with a value of 24 pixels to give it some breathing room. Add border radius and padding to the tab bar and remove the default padding from Ionic column using Ionic's built-in CSS properties. Set a fixed width for the column, align its content to the center, and apply cursor pointer as it is clickable. Finally, add some spacing between the icons. Some of the icons might not load properly right now. That's kind of limitation of the Rive package. It can have trouble rendering multiple icons at once. To work around this, we'll use a show property on each tab item to conditionally render them. In ng-on-init, we'll loop through the tab items and trigger a set timeout for each one, adding a small delay so that they render one after another. This helps prevent the issue and ensures all icons load correctly. It's not ideal, but until the package improves, this workaround gets the job done. Next, we want the selected tab state to be controlled from the parent component. since we'll be using that to conditionally display each tab's content. So in the bottom tab bar component, create an input called selected tab and set its default value to the first item in the tab array. Then in the parent component, define a state variable with the same name and default it to the same first tab item. Then pass that value down to the tab bar component via the tag in the HTML. Now to update this value from the tab bar itself, we'll create an output event emitter called onTabChange. Inside the onIconPress function, we'll emit the clicked tab item through this event. Then in the parent component, we'll update the selected tab state when we receive that callback. Now we can track which tab is selected and respond accordingly. Let's add a visual indicator for the active tab. In the tab item layout, add a div with the class activeIndicator. Set its height to 4 pixels, give it a color from our theme, and add a border radius of 2 pixels. Since it's affecting icon's positioning, we'll wrap it inside another container and set that container to position absolute. Use left 0 and right 0 to stretch it fully and position it with top of -4 pixels so it appears just above the icon. Now let's control the indicator's width with a CSS class. Create a class called expand and use ng class to apply it conditionally for the selected tab. Center the indicator using flex styles. It's working, but let's animate the indicator for a smoother effect. In CSS keyframes, animate the width from 0 to 20 pixels between 0% and 100%. Then apply this animation to the expand class with a short duration and easing. Now the indicator slides in nicely when the tab becomes active. Let's add a gradient to the bottom tab bar. And just for testing, we'll start with red and green so we can see it clearly. Add some padding, border radius, and a border to shape it, and this is how it will look. Change the border to 0.5 pixels and use a color that's a mix of white and transparent. It may not be fully visible right now, but once we add more screen content, it'll blend in better, just like in the original app. Finally, let's add a subtle box shadow to lift the tab bar visually. One last fix, if you click the already selected tab, it still plays the animation. To prevent that, add a condition in the click handler so that the animation only triggers if the click tab is not the currently selected one. Now that the custom bottom tab bar is ready, let's move on to the tab screen. First, we'll create a content view component inside the views folder. I'll change the selector name and import the required modules. Then import this component in the root and add the CR content view tag in the HTML. Inside the content view HTML, we'll start with the title using the large title font variation from our global theme. Right now the title is appearing behind the notch, so we'll wrap the entire content in a div with the class home tab container and apply top padding using the safe area inset. Next, we'll create a file in the models folder called course and define a dummy array with properties for the card selection. Import this course list array into the content view component. In the HTML, create a course container div to hold the card layout. Add a title and subtitle. For now, we'll use values from the first item in the array. Apply display flags and flags direction column to the container. Add a gradient background, white text color, padding, and border radius. Wrap the course title in a course title class and apply a margin bottom. For the subtitle, reduce the opacity slightly to give it a dimmed effect. Below this, add a caption with vertical spacing. Next, we'll show a row of user avatars. Use an Ionic row to render an array of images and add track by to assign a unique ID to each. Wrap each image in a container with the avatar container class. Set fixed width and height for the images. Apply border radius and use overflow hidden. Add some spacing between each avatar. To stack the avatars slightly on top of each other, we'll apply an inline transform style. In the HTML, translate x each image by minus 20 pixels multiplied by the index. This creates the overlapping avatar effect we're going for. Right now the card stretches across the full width of the screen. Let's limit it to a fixed size so we can render it as a horizontal list. Add a spacer div with flex1 to separate the avatar row from the card's content. Now we'll add the course image. Set its width and height and position it absolute in the top right corner with top 20 pixel and right 20 pixels. The image is currently positioned relative to the root. To fix that, we'll set position relative on the card container. The image is also clipping the title, so we'll reduce the title width to 170 pixels. Finally, we'll add a box shadow to lift the card visually. Now let's render the full list of horizontal cards. Add an ng for loop on the card container and use track by for unique ID for each item. By default, the list renders vertically. To change that, wrap the cards in a wrapper div. Set display to flex and disable flex wrapping. And apply overflow X to auto to allow horizontal scrolling. Add some padding to the container to space things out. Right now the card sizing isn't consistent. They shrink based on the content. To fix this, apply flex of 0 space 0 space auto to each card, where first is flex grow, second is flex shrink, and last is flex basis. This means no growth, no shrink, and keep the width defined by the content. Add spacing between the cards as well. Finally, replace the hard-coded card content with the dynamic values from the array. Now if the subtitle is too long, it might overflow the height of the card. To handle that, we'll limit it to 2 lines using CSS and show ellipses after that. In our dummy data, each item has a unique RGB color code. To use that in the background, we'll assign it to a CSS variable --course-bg. Then use that variable for background and shadow styling for the card. Optionally, we can hide the horizontal scroll bar for a cleaner look. Finally, let's add some horizontal margin to the section title to align it properly. With the horizontal card section done, let's now build the vertical list for the recent courses section. First, import and declare a dummy array for the recent courses, just like we did for the previous section. In the HTML, add an Ionic column to lay out items vertically. Inside that, create an Ionic row and add the course title, a caption, and a course image. Wrap the title and caption in one Ionic column and wrap the image in a separate one. Set the image column container size to auto so it only takes up the space it needs. Add a BR tag between the title and caption to show them on separate lines. Set the background color of the row using the color from the array item. Wrap everything in a container with the class section container. In CSS, remove the default padding from the child Ionic column. Set a fixed height, white text color, border radius, padding, and alignment vertically center. Set a fixed size and margin left for the course image. Add some spacing between the title and the caption. To make this list responsive, wrap the items inside an Ionic grid. Inside the grid, place the list item in an Ionic row. Now let's apply ng4 on the list to render each course. Use size of 12 on the Ionic column to ensure that it spans the full width. In CSS, update the default grid padding and do the same for the child column elements. Finally, make sure the list is using data from the array and add some bottom padding between both sections. Now, one small improvement. Let's randomize the avatar list for each card so it doesn't always appear in the same order. To do that, we'll create an Angular pipe called shuffle-array in a helpers directory. In the pipe, use the built-in sort method to shuffle the array and return the result. Import the pipe into the content view component and apply it using the vertical bar character with the pipe name syntax inside the ng4. Now the avatar order appears randomly each time. You might also notice the screen isn't scrollable right now. So go back to the root course Rive component and wrap the content in an Ionic content element. Make sure to import Ionic content from the framework. I will also import the other components we will need for this page. Now the screen scrolls properly. Next, we'll update the screen's background by setting it from our global theme, and we'll hide the vertical scroll bar for a cleaner look. Now, to show and hide the tab screen based on the selected tab, we'll import the bottom tab item array into the root component. In the HTML, add a condition to only display the content view if the selected tab is the first one. For the other tabs, just display the tab title as a placeholder for now. To center the title vertically and horizontally, give the placeholder complete viewport height and width and use flex layout to center the text. And it's working just as expected. Let's now give the bottom tab bar a polished look with a frosted glass effect. First, make its background slightly transparent. Then apply backdrop filter of blur 10 pixels to give it that soft, blurred look behind the icons. And it now feels much more refined. Next, we will handle responsiveness on the larger screens. Right now, the bottom tab bar stretches across the entire width of the screen, which doesn't look great on desktop. Let's limit the width to 768 pixels and center it using Margin Auto. Then apply the same styling in the HTML as well. The recent courses list is also stretching too wide. On larger screens, we'll switch to a grid layout by applying size-lg to 6 on the Ionic column. This makes each course take up half the screen's width on desktop while keeping the full width on the mobile. Lastly, bottom tab bar is covering part of the screen content. To fix that, we'll add bottom padding to the scrollable area. Include both the safe area inset and an estimate for the tab bar height. Around 60 pixels should do it. Now everything is spaced correctly, looks great, and scrolls as expected. And that completes the second module of our app, the bottom tab bar and the tab screen UI. So first we'll generate the side menu component. Then I'll change the selector name and import all the components and modules we'll need for it. After that, make sure to import the side menu component into the root course Rive page. In its HTML, add the side menu tag with an ID and temporarily comment out the main content and the bottom tab bar. Now inside this side menu HTML, we'll start with an empty div that uses the class side-menu, which will take up 100% of the dynamic viewport height or DVH. We're using DVH instead of VH because it works more reliably on mobile Safari. Next, we'll set the background color using a variable from our global theme. Then we'll add top and bottom padding to account for the safe area insets. Next, in the HTML, we'll add an Ionic row with the class header. And inside that, we'll place the person outline icon. It's showing up, but it's black. So let's change the color to white. Next, we'll add the user's name and designation inside an Ionic column. Use a BR tag to display them on separate lines. And apply a padding of 12 pixels to the header div. Now to style the user icon, we'll give it a background color, padding of 12 pixels, a border radius, and a right margin of 8 pixels. Then we'll align the header content to the center. For the designation text, let's apply a slightly dimmed color. To show the side menu buttons, we'll add a div with the class section-container. Inside it, we'll create another div with class menu list section, which will contain first section of buttons. Add a section title called Browse and apply the sub-headline to font variant from our global theme. Next, we'll give this section title a slightly dimmed color and some horizontal margin. Now we'll create a new file called sidemenu.ts inside the models directory. This will store all the buttons data for the side menu. Then paste in the data for each section with their respective properties. Make sure to use exact property names. For example, the state machine name for home is home_interactivity with a lowercase I, but for other buttons, it starts with a capital I. Since we'll have multiple buttons, let's create a reusable component called menu row. In the component, change the selector name and import all the components and modules we'll need. Each menu button will get its own data from the parent, so we'll accept an input called menu. Now import the menu row into the side menu component and create a local variable menu items using the dummy data we added earlier. Finally, in the HTML, use the menu row tag and pass in the first menu items as input. Then inside the menu row component HTML, clear out the default content and start fresh with an empty div. Add an Ionic row with the class menu button container. Inside that, add a div to contain the Rive icon. Give it a fixed size of 32 pixels. Inside the canvas, set the state machine and the Rive input using menu's status property as the value. Then add the button title next to the icon. In the CSS, we'll add padding to the menu container. Align the items to center and set cursor to pointer. Fix the icon dimensions to 32 pixels and give it a right margin of 14 pixels for spacing. We'll also apply opacity 0.6 to dim it slightly and set pointer events none so the icon doesn't intercept clicks. Now the button is almost ready. To render the rest of the items, use an ng for loop and make sure to use track by to provide unique ID for each item. Finally, replace the hard-coded menu input to instead use the one from the list. Now if you notice, some icons aren't rendering properly. That's kind of a limitation with the plugin right now. To fix that, we'll render each icon with a slight delay. In the menu row component, conditionally show the canvas only when a local show property is true. And now the icons are rendering properly. Next, let's make a few layout changes to give it a more of a sidebar look. We'll set a fixed width, say 288 pixels, with a border radius of 30 pixels. In the menu component, we'll also add a separator between each button for better visual clarity. Now, to highlight the button that's selected, we'll create a div with the class menu-button-bg and give it a blue background, a height of 56 pixels, which matches the 32 pixels icon height plus the 12 pixels of vertical padding from top and bottom, and a border radius of 10 pixels. Set its position to absolute so that it appears behind the button content. It's not showing up yet, so we'll conditionally assign the background width if the current button's ID matches the selected menu, defaulting to home. We'll set its width to 272 pixels, that's 288 pixels, the sidebar width, minus 16 pixels of padding on the end. Otherwise, we'll set the width to 0. Now the background shows up, but it's covering the button text. To fix that, we'll add a Z index to the text element to bring it to the front. Let's also add spacing to the list of buttons. Apply a margin top of 40 pixels to the section container. Then wrap each menu row with the parent div. And apply padding, a margin top of 8 pixels, and position relative so the absolutely positioned background is relative to this div. Now, to trigger the icon animation on click, along with any other visual effects, we'll need a click event on the button. So we'll create an onPress event emitter in the menu row component and emit it when the button row is clicked. In the side menu component, we'll define a function called onMenuItemPress to listen to this event. The function will receive the button index and the selected menu item. Then in the HTML, call the function on the onPress callback. Inside the function, we'll set the status property of the clicked item to true. This works, but it causes the animation to keep playing in a loop. So to prevent that, we'll reset it by setting the value back to false after a 1 second timeout. That way, it only plays once per click. Now that we're getting a callback on the button click, next we'll animate the background. First, give the menu row tag an ID, something like menu items. Since it's a list, we'll use viewChildren to get a reference to all the menu items. Inside the onMenuItemPress function, access the array of element references and use a for loop to iterate through them. To perform the animation, we'll import Ionic's animation controller and define it in the constructor. Inside the loop, create a new animation for each menu item, target the element with the class name we gave to the button background, set the duration, and use from_to function to animate the width from 0 to 272 pixels. Finally, call the play to trigger the animation. Now the animation works, but it's being applied to all the menu items. So we'll add a condition: only animate the item if its index matches the one that was clicked. This improves it, but now the previous button's background stays active, so we need to track the selected item. Create a local variable selected menu and set its default value to the first item. Update this value whenever a button is clicked. Before updating it, also store the previous selection's index. Now in the loop, we'll update the if condition, trigger the animation only if the index matches the current or previous selection. Still, the previous background doesn't animate out. So we'll update the from_to values conditionally. If the item is currently selected, animate from 0 to 272 pixels, and if it's the previously selected item, animate from 272 pixels to 0. This creates a clean in-out animation. To smooth it further, let's provide a custom easing value using cubic Bezier for a softer curve. Next, we'll build the second section of buttons using the same logic. Declare a new array called menuItems2 and add the history section inside the HTML using this array. Assign it a new ID like menuItems2. To work around the same Rive icon rendering issue, we'll delay the rendering just like we did with the first section. Now the button animations work, but the background doesn't animate for this second section. So we'll get the references for this second list using viewChildren and merge both sets of references into a single array. Now the animations work across both sections, but we also need to adjust the last selected index logic. If the previous item isn't found in the first array, then get its index from the second array and add the length of the first list to offset it. And now everything works as expected. Finally, we'll add the dark mode toggle button at the bottom. Start by declaring a third menuItems variable, which includes just one item in the array. Next, in the HTML, add an Ionic item element that contains the Rive icon canvas on the left and the toggle button on the right. We'll apply the font headline variant from our global theme, set justify input to space between and use iOS mode, and label the toggle as dark mode. Now the Ionic item comes with some default styles. So we'll add a class called dark mode container and set its background to transparent. At this point, the text and toggle track aren't visible clearly. So we'll fix that by setting the text color to white and giving the toggle track a slightly dimmed white background. Next, wrap the canvas inside a div with the class icon container. Set its dimensions to 32 pixels, add a right margin for spacing, and slightly dim the icon color. Also apply pointer events none so it doesn't intercept clicks. To shift the dark mode toggle to the bottom of the sidebar, add a spacer div just above it and give it a flex of 1. This alone won't work, though we also need to make sure the main side menu container has display flex and flex direction of column. Lastly, tweak the padding on the toggles container so it aligns neatly with the rest of the sidebar content. Now we'll handle the toggle logic. Declare a local variable isDarkMode set to false by default. Then create a function called onDarkModeToggle inside it and assign the value of isDarkMode to the dark mode menu item's status property. In the HTML, bind isDarkMode to the toggle using ngModal and attach the onDarkModeToggle method to the IonChange event. Now, whenever the toggle is turned on, the dark mode icon will animate. Finally, don't forget to render this item with a slight delay, just like we did for the other buttons, using the menuItems show property. Now that the Sidebar UI is complete, let's make sure it is responsive across different screen sizes. It looks good on desktop, but on smaller screens, the content isn't scrollable due to limited vertical space. So to fix that, we'll add overflow via scroll to the section container. Optionally, we can also hide the scroll bar to keep the UI clean. And with that, our sidebar layout is done. Next, let's bring everything together, integrating the sidebar with all the other modules we have built so far, the onboarding flow, bottom tabs, and home screen. First, go back to the root course Rive component and uncomment the main content and bottom tab bar. You'll see that the sidebar now overlaps the home screen, so we need to fix that. Set position absolute on the content, but you'll notice the text and icons are still showing above. So we'll also assign a Z index to the content container. Now, to ensure that the bottom tab bar appears on the top, assign it a higher Z index, for example Z index of 2. Next, we need a way to open the sidebar from this screen. For that, we'll use a Rive asset that has two states, open and close, toggled using an input called isOpen. The process of creating this animation in the Rive editor is explained in detail in the original Design Plus Code course, so be sure to check that out. In the HTML, we'll add a Rive canvas with the file name menu_button and set its size to 44 pixels. Inside the canvas, add the state machine and bind the input named isOpen with a value of true. We'll make this value dynamic shortly. Now it's not visible yet, so we'll wrap it in a div with a class side menu button. Set its position to fixed and assign Z index of 2 so that it appears on the same layer as the bottom tab bar, above the content view. Then apply top to 16 pixels plus safe area and set top, and left to 16 pixels for margin from the top left corner. Then a box shadow for depth, a white background so the shadow renders correctly, then display flags to fit the content, border radius of 22 pixels which is half of the button's 44 pixels size, and cursor pointer to make it interactive. Also add pointer events to none to the canvas so it doesn't block the click event on the button container. Now in the component, declare a variable called isMenuOpen to track whether the menu is open or closed. Create a function onMenuToggle and toggle the isMenuOpen value when the menu icon is clicked. In the HTML, bind isMenuOpen to the Rive input value. Attach onMenuToggle to the button's click event. And now the menu button animation works as expected when toggled. Next, since the menu button overlaps the content, we'll add a top padding of around 60 pixels to the content view to create some space. And just like the other Rive icons, we'll also render this menu button with a slight delay to work around the plugin's limitation. Now it's time to animate the side menu and related UI when this menu button is clicked. First, assign IDs to the menu button, the content view, and the bottom tab bar in the HTML. Then in the component class, get references for all of them using viewChild. Let's start by animating the content view. Create a new animation function using animation controller and animate the transform from none to translate x of 288 pixels, which matches the sidebar's width. Now since we'll be running multiple animations together, create a group animation and set a shared duration of around 250 milliseconds. Now check the isMenuOpen variable. If it's true, call play to run the animation. It works, but then doesn't close the view when clicked again. So when isMenuOpen is false, call reverse to close the sidebar. And now the content smoothly opens and closes with the menu button. Let's enhance the animation further. Add a rotation along the y-axis, something like rotate y of -30 degree to give it more depth. It rotates, but it doesn't quite look right. That's because we're missing a perspective value. So add a perspective transform to give it that 3D feel. Now you might wonder where this perspective calculation comes from. It's actually adapted from a Stack Overflow solution that helps calculate perspective dynamically for different screen sizes. While there isn't a clear explanation behind the math, it seems to work well for our layout across various devices. Finally, add a scale down transformation to shrink the content slightly as it moves aside. Now that the content is transformed, it becomes harder to see clearly. So let's add a background behind it. In the HTML, add a div with the class screen_background. Then in the CSS, apply a background color that matches the sidebar. and style it to cover the entire screen area. To complete the look, apply a border radius of 30 pixels to the content and set overflow hidden to make sure the rounded corners work correctly. This gives the app a clean, polished depth effect. Next, let's animate the menu button itself so that it slides out with the content. In the on menu toggle function, add a new animation for the menu button. Apply a transform of translate X of 216 pixels when the sidebar is open and pass this into the animation group along with the content animation. Now it moves together with the content, nice and clean. It looks good so far, but we can make it even better by animating the sidebar itself. Create a new animation for the side menu with the translate X in the opposite direction and rotate Y of 30 degree, mirroring the content's rotation. For perspective, since the sidebar has a fixed width, a hard-coded value like 700 pixels will work just fine here. Add this to the animation group as well. And now the transition looks much better. Lastly, let's animate the bottom tab bar. Since it overlaps the sidebar content, we'll slide it down by 300 pixels using a translate Y transform and include it in the same animation group. Now all the sidebar animations are working, but there's one last issue. The transformations from the animation controller only apply after the menu button is clicked. That means on initial load, the sidebar is still visible underneath the content. To fix this, we'll apply the same initial transform values directly in the CSS so the view starts in its animated position even before any interaction. Next, we'll integrate the onboarding UI into the full app. To display it, we'll add a new button with a person outline icon. Set its position to fixed with a top offset of 20 pixels plus safe area inset and a right of 16 pixels. Give it a Z index of 2 so it appears in the same layer as the bottom tab bar and the menu button. Then style it with a white background, fixed size of 36 pixels, flex properties to center the icon, border radius for roundness, a subtle box shadow, and for the icon we'll add a stroke width, black color, and cursor pointer since it is clickable. Now assign an ID to the button and get its reference in the component class. Since we want this button to animate out of the view when the sidebar is opened, we'll add an animation inside the on menu toggle function that moves it to the right by 100 pixels. And it works as expected. Next, declare a boolean variable showOnboarding to control the visibility of the onboarding view. Then create a function showOnboarding toggle to toggle this value and call it in the HTML when the new button is clicked. Now, uncomment the CR onboarding tag in the root component. To make sure it sits above all content, we'll give it a position absolute and a Z index of 3 so it appears on top of the content view. Before we animate the onboarding screen, we'll add a close button to its layout. Inside the onboarding component, add a button with close outline icon. Then set its position to absolute with top based on the safe area inset and right of 16 pixels. To align it better with the onboarding content, we'll add an additional top margin of about 100 pixels. And for styling, update the background for normal, hover, activated, and focus states. Set its size to 36 pixels, remove default padding, add border radius and box shadow, set icon's font size to 24 pixels, and finally apply cursor to pointer. Next, let's create a custom event emitter to notify the parent when the onboarding screen is closed. Call it close onboarding event and emit the event from the close onboarding function when the button is clicked. Back in the parent component, listen to that event and hook it into a handler function. Before animating, we'll give the onboarding component an initial transform value of translate y minus 100% of the viewport height to position it off screen. Now for the animation, first assign an ID to the onboarding component and get its reference in the class. Now in the show onboarding toggle function, create an animation that slides it from translate y of minus 100% of the viewport height to minus 100 pixels. This leaves a little space from the bottom for visual separation. Since we are animating multiple elements again, create an animation group and set the duration to 500 milliseconds. Play the animation when show onboarding is true. It works, but doesn't animate out when we close it. So we'll add a reverse animation when show onboarding is false. And now it transitions in and out smoothly. And to make it even better, add an easing of ease in out to the animation. Now let's polish the onboarding model style a bit to make it look more like a model. Apply a border radius of 30 pixels and don't forget to set overflow hidden to make the radius work. And a soft box shadow. Now it looks much cleaner and clearly separates from the background. As we show the onboarding screen, we'll also scale down the content view slightly. So in the same animation group, animate the content to a scale of 0.92, just a subtle zoom out. Lastly, animate the bottom tab bar by translating it downwards slightly. And now the onboarding screen flows in beautifully with everything synced and polished. Now the bottom spacing on the onboarding screen isn't quite aligned with the content scale. So instead of using a fixed value, we'll calculate it dynamically. Create a variable called transform bottom and initialize it with 100 viewport height. Then subtract the product of 100 VH multiplied with 0.92, where 0.92 is the scale applied to the content view. This subtraction gives us the remaining height not covered by the content, but it includes both the top and bottom spacing. So divide the result by 2 to get just the bottom part. Now it lines up perfectly with the content view. Apply this calculation value in the onboarding animation. To reveal a bit more of the content behind, we'll add an extra 20 pixels to the result. And finally, add it to the initial value as well. Add another 40 pixels to account for the box shadow area, making sure the onboarding is completely off screen when hidden. Now it works perfectly. But since the animation only triggers after interaction, we still briefly see the onboarding when first opening the app. To prevent that, apply the same transform value in the CSS as an initial style. And with that, the onboarding integration is complete. Next, you might notice that when we open the sign in view, the close button isn't in sync with the animation. So to fix it, give the close button an ID, get its reference in the component class, and in the enter animation function, animate it with translate Y of minus 150 pixels so it slides slightly out of the view. Now that looks much better. We're almost done, just a few final touches. In the root component, let's add a white underlay behind the bottom tab bar. And in the CSS, set its position to absolute and anchor it to the bottom. Assign a Z index of 2 so it layers correctly. Then apply a top to bottom gradient background from transparent to a whitish color from our theme. Then give it a fixed height of 150 pixels and a full width, and set pointer events to none so it doesn't block any interactions. It adds a nice touch to the UI, but we should hide it when either the sidebar or onboarding is visible. So give it an ID and get its reference in the component. Then animate its opacity to 0 when the onboarding is shown. And do the same when the sidebar opens. And that completes the polish. Now let's run the app on Android as well. Now you'll notice that when the sidebar opens, the status bar text black color becomes hard to read on the blue background. Using Capacitor's status bar plugin, we can fix this by toggling the status bar style. When the sidebar opens, switch to dark style, which tells the system that the background is dark, so it automatically makes the text light and vice versa. And aside from that, the app works the same on the Android as well. But if you look closely, on Android the content renders behind the status and navigation bars, and it doesn't respect the safe area spacing the way iOS does. That's because we're currently using Ionic's built-in safe area variables, which only return values for iOS. So to fix that, I'm using a plugin that I created called Capacitor Status Bar Safe Area. It provides CSS variables for both platforms. On iOS, it gives you the usual safe area insets, and on Android, it includes the status and navigation bar spacing. Then make sure to run npx cap sync to sync the plugin and run the app again. Next, to be able to use the CSS variables from the plugin, we need to inject them. So in the root app components constructor, inject the variables using the plugin's setup function. Finally, replace all usage of ion safe area with the new safe area inset variables throughout the app. And now the app has much better spacing even on Android. Lastly, let's test responsiveness on desktop screens as well. Everything looks clean and adaptive, and the layouts seem to hold up well across the screen sizes. And with that, our application is complete. It runs on Android, iOS, and the web, and handles responsiveness and polish on all the platforms. If you found this tutorial helpful, please like and subscribe, and feel free to leave a comment if you have any questions, suggestions, or just want to say hi. I hope you enjoyed the tutorial, and I'll see you in the next one.